Hello everyone and welcome to the introduction for Chem 492 CT3, Discovering the World of Organic Chemistry. What you'll first notice about this slide is all of the drug molecules located in the background. While you may be familiar with most of the names of these drug molecules, you're probably pretty unfamiliar with the organic structures of each of these molecules. By the end of this course, you'll be able to interpret any one of these molecules on your own, as well as many other concepts not related to pharmaceuticals that are involved with organic chemistry. In order to begin to understand organic chemistry, we must first gain an understanding of the periodic table. While I do not expect anyone to memorize the locations of each of the elements of the periodic table, there are certain elements that are more important than others when talking about organic chemistry, as well as certain trends that exist between these elements that you will have to become very familiar with. For this exercise, you are to draw in all of the missing elements that are located in the white boxes of this periodic table. You are to identify the group numbers above each column of the periodic table, and then you are to place dots representing the valence electrons. As an example, boron and oxygen are done for you. Boron is a group 3 element, so all of the elements in this column are group 3, and notice that boron has 3 valence electrons surrounding its shell. If you identify all of the missing elements as well as indicate how many valence electrons each individual atom has, you are to use the next slide to assign electronegativity values to each of these elements, and rather than tediously writing out the values of each element, see if you could notice any overall trends for electronegativity values and atomic radii. What I'll recommend you do is to pause this video right now and to proceed completing this table yourself as practice, as everything you do here will become important for the remainder of this entire course. So now that you've had a chance to complete this table, I'm going to go ahead and reveal the answers. So you notice the group numbers aren't too hard. It goes 1, 2, 3, 4, 5, 6, 7 from the left to the right. We could see all the missing elements. All the elements in group 1 have 1 valence electron. All the elements in group 2 have 2 valence electrons, and so on. What you hopefully picked up on are the trends that are also located within the periodic table. The trends that we mentioned are electronegativity. So if you took a look at those values in the table on the next page, if you go up and to the right, you'll notice that electronegativity values increased, which means fluorine would be the most electronegative atom located within the periodic table. On the other hand, if you took a look at each of the atomic radii, you notice that as we move down and to the left, the atomic radii increase, making potassium have the largest atomic radii of any of the elements that we've identified here in this periodic table. So just to reemphasize this point, the values in this table are not important to memorize. What is important to memorize are the trends that we just mentioned, as in electronegativity increasing up and to the right within the periodic table, and the atomic radii of atoms increasing down and to the left. So the question now becomes, why are we discussing valence electrons and the periodic table? Well, the trends for electronegativity as well as atomic radii will come into play a little bit later in this course, but valence electrons are immediately important. Valence electrons are important in chemical bonding. They take part in chemical reactions, and in order to begin to understand organic chemistry, we need to first understand the valence electron trends. So just as a reminder, we're discussing the outermost electrons when we speak of valence electrons. So for example, a carbon atom, which has an atomic number of 6, meaning it has 6 protons and 6 total electrons, it's a group 4 element and therefore has only 4 valence electrons. So that's a very key point to realize when we're speaking of valence electrons. As a lesson summary, let's go over the important topics that were covered in this first lecture. The first one is the organic chemistry only deals with a small subset of the periodic table. So while memorization of every element is not important, a strong understanding of the location of the important organic elements, the number of valence electrons they have, as well as the various trends that exist between them, will be very important. And finally, valence electrons are the outermost electrons. They're involved in chemical bonding as well as reactivity and are very important to understand. In order to test your understanding of the concepts covered in today's learning module, you may proceed to Part 1 of the Building Blocks learning module located within ACE.